All right, this is known as a KWL, what I already know, what I want to find out. This is what I learned. We have f of x equals 5x and g of x equals x plus 2. Find the following: f of x plus g of x, f of x minus g of x, f of x times g of x. If you already know this, then try the problem in this column. If you're not sure and you want to find out, put it in this column. If you have no idea and you've added some things, this is what I've learned. You're going to write it in this column. So go ahead and try these problems and we'll see how you did. A says f of x plus g of x. That would be 5x plus x plus 2. 5x plus x is 6x plus 2. Final answer. I bet you knew how to already add that, and you probably already know how to subtract them. That is f of x subtracting g of x. We have f of x minus 2. That would be 4x minus 2. Final answer. The next problem says to multiply them. That would be f of x times x plus 2. 5x squared plus 10x. Final answer. Maybe you're wondering about the dividing one. Maybe you did the dividing in this column. It doesn't matter which column that you do it in. This is usually a lab that we do during class. And I'm going to do f of x divided by g of x here. F of x divided by g of x. What do you think? That is a final answer. Let's talk about power functions. Y equals ab to the x. F of x equals 4x to the 1/2, and g of x equals negative 9x to the 1/2. We are going to add these together. Do you know how to do this? Is this something that you need to find out? What have you learned so far? What is the rule for adding and subtracting variables? They need to have exactly the same variables and exponents, which we do. 4 minus 9 then is negative 5x to the 1/2. C says to find the domain of f plus g and f minus g. What is the domain of this function? Well, we know that for x to the 1/2, that is a square root. I could rewrite it as negative 5 square root of x. Are there any problemed areas with square roots? We cannot have negative numbers. A negative number would be imaginary. That is the place that we need to look out for. We would say that the domain then would have to be non-negative real numbers. All non-negative would be 0, 1, 2, 3, and so on. Non-negative. How about f of x minus g of x? F of x minus g of x. So that's 4x to the 1/2 minus g of x. Watch out for those double negatives. And here we get 4 plus 9, so that would be 13 x to the 1/2. And again, this is going to be the same. Remember that these are even roots. That's the square root and even root. If it was an odd root, it would be all reals. any even number, you cannot have negative numbers. So again, for this one, the domain, all non-negative real numbers. So maybe something that you learned today is that even roots and an odd root is going to be all the reals. That would be the domain. If it's even, non-negatives. If it's odd, it's all the reals. We can have negatives underneath the radicand when it's an odd root. F of x equals 6x, g of x equals x to the 3/4. Find the following. We're multiplying them together. 6x times x to the 3/4. How do we multiply variables? We add their exponents. This will be 6x to what power? We're adding exponents. So we have 4/4 for 1. So 4/4 plus 3/4 is 7/4. What is the domain? Question is, do we have an odd root or an even root? This would be 6, and then it would be, here's my index number, the 4th root of x to the 7. We have an even root. So the domain would be all non-negative real numbers. F of x divided by g of x. 6x divided by x to the 3/4. Again, we are going to fractions. Fractions are the other problemed areas. So we have even roots. We can't have imaginary numbers. The other area that is a problem is when there's a 0 in the denominator. A 0 makes it undefined. Domain areas to look out for. 1, imaginary numbers, and 2, undefined. When zero's in the denominator. Those are the only 2 problems in the domain that you will have. We've been talking about even roots and why they have to be non-negative real numbers. And here we have a fraction. We really need to be looking out for those problemed areas. What would make this denominator 0? Whatever number would make that denominator 0, that's the problem in the domain. If I tried 0, if we substituted in 0, what would it look like? 6 times 0, and then 0 to the 3/4. So 0 cannot be in the domain because it's a problem. It's undefined. So the domain for this one cannot be 0. That's the only thing that would fit here. If I put 1 here, it'd be 1 to the 3/4. That would be fine. This one is going to have to be all positive real numbers. Domain areas to look out for. Example 4, f of x equals 2x minus 7, g of x equals x squared plus 4. What is g of f of 3? G of f of 3. You're putting a function f into g. You're putting 3 into the function f, and that answer is going to be put into the function of g. You need to start from the inside and start with f of 3 first. F of 3 equals 2 times 3 minus 7, 6 minus 7. F of 3 equals negative 1. That's the first step. The next step is to take f of 3 and put it into g of x. So we have g of f of 3. I have my g of x function. There's my x, so it's going to be x squared plus 4. There's g of x, and I'm taking f of 3, and I'm putting it into the function. So g of f of 3 equals negative 1 squared is 1, and 1 plus 4 is 5. Example 5. Let f of x equal 4x to the negative 1 and g of x equal 5x minus 2. And then we need to find the domain of each composition. So f of g of x. G of x is in f. So first you start with your f function, and you put a parenthesis wherever you see the x. There's my x to the negative 1. Here is f, and now I'm going to take the g function and put it in there. 5x minus 2. And then you need to simplify. I see a negative exponent. What's being raised to the negative exponent? Whatever's being raised to that negative exponent, that's the only thing going in the denominator. Here's my parenthesis, and there's my negative exponent. There's nothing wrong with the 4. The 4 stays. So the 4 stays in the numerator. 5x minus 2 is now to the positive power. So that's just 4 divided by 5x minus 2. Now, when we're thinking about the domain, there's only 2 areas we need to watch out for. Do we have a possibility of imaginary numbers here? Do we have a possibility of getting an undefined function if we have 0 in the denominator? The question is, what would make the denominator 0? What would make the denominator equal 0? Well, use some algebra. What would make the denominator equal 0? And solve for x. Shift 2 over to the other side, divide by 5, and we get x equals 2/5. That is the only number that would make the denominator equal 0. So that means that all real numbers will work except 2/5. Now we can do a composition of g of f of x. These are called compositions. Compositions of functions. G of f of x. G of f of x. That means that f of x is going into g. So I start with g. I'm starting with g, and I'm putting parentheses wherever there's an x. There could be one of them, 2 of them, whatever the function is. G of x is 5x minus 2. So that's 5. Here's my x minus 2. And f of x is what I'm putting into the g of x. F of x is 4x to the negative 1. I need to simplify, and I get 20x to the negative 1 minus 2. Do I have a negative exponent? The only thing that has a negative exponent is the x. That's going to be 20 divided by x to the 1 minus 2. G of f of x. Do I have a problemed area of imaginary numbers or an undefined function? All real numbers except what would make the denominator 0? 0. Now we have f of x. It's still a composition. So I start with f. F is 4x to the negative 1. So I have 4. I put a parenthesis where my x is. And I put negative 1. There's 4x to the negative 1. I only put a parenthesis where the x is. And now I need to substitute in f of x again. What do we have here? I am going to start with applying the exponents. I have a product being raised to negative 1. So that's going to be 4 times 4 to the negative 1 times x to the negative 1 being raised to the negative 1. Power to a power, I multiply, and that makes it a positive 1. All right, the only problem area I have here for a negative exponent is the 4. I have 4 times, this is going to be in the denominator, 1/4 times x. And that makes it 1/4 times x. If I make this a fraction, just multiply straight across and we get x over 4. So I have 4 times x over 4. And now I can cancel my 4's here. And we get that f of x equals just x. In the domain here, all right, this one is a little bit tricky for the domain. It's all real numbers. Except 0 still, because 0 is not in the domain of f. This one's a tricky one. You would think it would be just all real numbers, but because from the beginning 0 would not be in f, it's not going to be in the composition of f of x. You won't see too many of these ones. They'll pretty much be straight up, as we've seen.